and that would cause more effective collisions so that we can dissolve something faster. Here's a different one, sodium chloride. So it is related to temperature. Obviously, the higher the temperature, the greater the solubility. So remember this little picture, we talked about solvents and how they dissolve solutes. And so it's when these attractions between the solvent and the solute are greater than the solute-solute attractions. If the solute is attracting the other solute particles with a greater force than the solvent can, it will stay together and it would be insoluble. So solubility, or how much dissolves in a given amount of solvent, depends on the bonding type and intermolecular forces. We spent a lot of time identifying intermolecular forces, and this is where it's going to pay off. You might have heard that term, likes dissolve likes. So things that are similar dissolve in each other. So for example, water is a polar solvent, and if I were to draw a molecule, you know that the oxygen end is slightly negative, the hydrogen end is slightly positive, and that is going to attract a negative end of maybe an ion or another dipole, and then the negative end of the molecule will attract something that is positive. So polar substances dissolve polar substances and ionic compounds. Okay, and similarly, if we have a non-polar solvent, a good one would be carbon tetrachloride. That is non-polar, and you can picture that molecule. It's symmetrical, and so it is non-polar. It would also dissolve other non-polar substances. Okay, and so that's what likes dissolve likes mean, solutes. Okay, let's continue on with the ionic compound. This picture is probably in your textbook. You need to be able to articulate how ionic compounds dissolve in aqueous solution. So remember, we've got a slightly negative end, the oxygen end, slightly positive end is the hydrogen end. And so the positive end of the molecule is going to be attracted to the anion, and then the negative end of the molecule will be attracted to the cations, and they will surround those ions and literally pull them away from that crystal lattice of the ionic compound. Now, what is an electrolyte? We've all heard of that. It is nothing more than a substance that dissolves and breaks up into ions in water, and then those ions conduct electricity. Okay, and so here's a little example. If we put ethanol into water, it would not conduct electricity. There are no ions present. It's a solution, but no ions are present. If we drop in our potassium chloride that we just saw, we have potassium ions and chloride ions, and so it would conduct electricity, and you could literally run current through that solution and light up a light bulb. So that is an electrolyte. Now, how do we increase the rate at which we dissolve something? These are common sense. You have to think, what increases the collisions? And so if we increase collisions, how do we do that? That's the old kinetic molecular theory. Remember that? So how do you do that? Well, one, you can increase the temperature. Higher temperature, higher velocity, higher kinetic energy, more collisions per time. Stirring, more collisions per time. If we reduce the particle size, we increase the surface area, and that would cause more effective collisions so that we can dissolve something faster. Now, let's look at a solubility graph. This is something that's really important. Typically, these things are given in grams per 100 grams of water in this case. Usually we're talking about the solubility in water. So this little line tells you at a given temperature, whatever temperature we're talking about, how much potassium nitrate can you dissolve in 100 grams of water. Here's a different one, sodium chloride. So it is related to temperature. Obviously, the Higher the temperature, the greater the solubility. You will probably be using a table like this. What do these lines mean? There are a couple terms. If you are below the line, okay, so I'm going to highlight a line. Let's do the old, potassium nitrate line. Okay, so here's my potassium nitrate. There's a lot of substances on each graph, okay? So if we are below the line, okay, at a given temperature, say I'm down here, 60 degrees, and I've got maybe 65 grams in 100 grams. That's an unsaturated solution. To get saturated, I have to go to the line, and that would be my saturation point. That is the maximum amount of solute I can get in 100 grams of water. And then if we get above the line, somewhere up here, that would be what's called a supersaturated solution. And that's a little tricky to make. But that's how you read these solubility graphs.